Uh, Yesterday I discussed about basics of current electricity. I didn't explain too much, like jet velocity. Student, you can say current, current density. I gave a thoroughly formula like mobility of charge carrier. And end of the session, student, I discussed that is what, my dear, KCL. So, student, this is the last question of yesterday class, right? So, in today lecture, beta, I'll discuss in detail. That is what, my dear, uh, further numerical, you can say like. Okay, so student, this is the first numerical for today class. Student, this is first numerical for today class. So, lecture number, this is what, two. This is what, my dear, lecture number two. Okay, fine. So in this lecture, beta, what numerical only, numerical maximum. Find, 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 student, find flow of current in each wire, each wire of circuit. Circuit diagram shown. Circuit diagram beta G shown. Okay, so have a look, my dear, of circuit diagram. Okay, yes, beta. So I can say this is diagram, my dear. Take anything. Student, first I'll draw the diagram, then I'll give you data. But there is no battery at all. This is circuit, my dear. It's quite simple. Yesterday I did this question, but different way. Beta, yesterday I did this question, yeah, but that is students in different way, right? So just we'll go through this. Beta, all resistance in the circuit, you can take 2 ohm. This is beta 2 ohm, 2 ohm, 2 ohm. This is beta 8 volt. You can take 10 volt. This is 2 volt, and this is beta Z. You can see 2 ohm. All are beta in resistances in ohm only, and I guess all resistances of values beta. This remains in 2 ohm only. What we wish to find flow of current in each part of the circuit. Okay. So beta, I do these questions, and beta as yesterday I did these questions. These two are very similar. These two are very similar. What's the differences beta? Yesterday I have taken here, you can see this is what V volt by 3, right? But here you can say for this condition, there is what? Resistor. There is what? Resistor. So we study beta what I have taken. This is what I can junction point X, which is common. And here what's the drop? Which is what you can say X minus 5. Which is what, my dear? You can say X minus 5. Right. Okay. So which is for further step. What's the point? I can just conclude. So beta, for this condition, these two differences have taken X. This is what X minus 5, because what's the top? 5 only. But here, student, just keep in mind what's the point which I can take in consideration. Because these two are different potential. So you can't take this drop and this drop, both are equal. No, 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 no. You can't do this. This thing, this is wrong only. So beta, here I'm doing this is student X and this is y. Beta, this is x and this is what? Y. Okay. So beta, one time we have to start apply KCL at this point. One time beta KCL at this point. So student here, I'm considering delta suppose this is what current I1, I2, I3, I4, right? And according to beta KCL, what you can say, entire current at the junction point must be what goes to zero. So student, again I'm highlighting right here. This is I1. Beta this path, the student, I'm considering here I2. This path, my dear, I'm considering here I3. And beta this path, what I'm telling, this is what I4. This is what, my dear, I4. Then bacha, I can say in solutions, my dear, summation of current which is equal to zero. So this is what, my dear, I1 plus I2 plus I3 plus I4 is equals to zero, beta g. I1, I2, I3, I4 is equals to zero. What's iron beta? I hope all of you remember it. It's the basic definition of current. This is what you can see beta. I is equals to V by R, or you can see beta delta V by R. Both are remains common, my dear. So here you can write the party for I1. This is what X is a higher potential junction point. Student, keep in your mind junction point always at higher potential. So this is X, which is you can say X minus beta. This is what, 0. There is no potential difference at all. X minus 0 बच्चा party. Right. Then बच्चा X minus 0. अपन बेटा what? This is what? 2. What is I? V by R बच्चा party. Uh, ladder circuit. Yes, woman beta I'll do. I'll do बच्चा जी. Woman beta literally I'll do बच्चा. But beta slowly बच्चा. Just now beta. This class has started, my dear. I'll do all the questions, woman beta. Don't worry. I'll do बच्चा party. So this is beta X minus 0 by 2. If you are continuously available, then I'll take care classes, right? According to you only. So I'll take more numerical bacha. So BST in beta in live session. Now bacha x minus 0 by 2 bacha. Then beta what you can say? X minus plus 2 minus minus bacha. X minus 2. X minus 2 no. It's a 10 bacha. X minus 10 by 2 plus beta. X minus plus minus minus bacha. X minus 2. Beta there is a register here. Yes, beta. There is that which is what you can see 2 ohm. X minus 2 by 2 plus beta g. X minus by 2. X minus by 2 which is equals to 0. Beta g which is equals to 0. Now which just beta take LCM beta. Then you can see entire goes to beta 2 to 0 only. So 1x, 2x, 3x, 4x, 4x minus by is equals to beta. This is 10 and 2, 12. So you will get beta 4x minus y is equals to 12. Let us see equation number 1. Now beta, one time I applied junction law over here. Now beta, I'll apply junction law from here on at point by, at point by y only. Right. So you can see beta, this is what I1, I2. I have taken here I1, I2, I3, I4. So you can see this is what basically I5, I6, and beta G, I7. Nodal analysis, beta not in our syllabus. My dear, nodal analysis beta not in our syllabus, beta. Just nodal analysis, beta party. I can see nodal analysis sometime in few questions you can apply, but you can solve the numerical without nodal analysis, not required at all. Without nodal analysis, beta, you can also solve the question, beta party. In my class, I'll not do any questions from nodal analysis, but you can solve entire circuit. You can solve the entire circuit, my dear. So now beta, this is y minus x. You can say this is beta z. Now you can see in step 1. So now step 2, my dear. So y minus 2. Y beta what you can say? Minus x y minus x by 2 plus beta z. This is what I can say. This is remains by. So beta there is no difference at all. We can say by minus 0 by beta z 2 only. plus beta by plus minus minus by minus 8 by 2 is equals to 0 बच्चा 2 2 beta आंसर इंटर कैंसिल बच्चा what you can see 1 by 2 by 3 by minus x is equals to 8. Say equation number 1. Say equation. Sir, can you solve this question using nodal analysis? Just one. No, bacha. Uh, no, bacha. Because without nodal analysis, bacha, we can solve the questions. Without nodal analysis, it's a bit. I can say nodal analysis little bit lengthy, right? So I never ever I can say use for R grade. Yes, nodal analysis was applicable for BTech first semester. It will go now to just because there is applied physics. So there you can apply bacha party, right? Here you can leave bacha party. Here without nodal you can solve the question bacha. So now beta we have a two equations to unknown bacha party. Further we can solve. We'll get x and y. Then you can find what current in all the circuit. Because it then you can find current bacha in all circuit, right? Okay. Uh, just beta move ahead. Further you can solve bacha party. It's easy. It's not tough. Now beta what's the question next? Question remains same bacha. Find find flow of current in the circuit. Find students. Find flow of current. The questions remain same. Find flow of current in it circuit. Okay. So now I'm going to show a circuit. You can see bacha. This is it 2 volt. Beta first I'll draw diagram bacha party, right? Then I'll give you data of the question. Now if just stay here at phase 1 live session, definitely it will improve. Yes, fine. Now beta I'll take data of the question here. You can take bacha. Usually for my own easy calculation, always I have to take resistance 2, 2, 2, 2. Battery bit I can take here. This is 2 volt, 4 volt. You can take beta 10 volt and 2 volt. Right. So questions we have to find remain same. Question bacha ji we have to find remains same. Okay. So let's have a look at the solution of the questions. And have a look of the what? Solution of the questions. Right. Okay. So Bachaji, here I can say, beta, first you have to simplify the circuit. First, beta, you have to simplify this much circuit only. I'm talking beta this much. You can beta first simplify this. So what beta I can say this one minus to plus plus. Let us suppose you are moving from like this. So plus to minus minus. So 4 minus 2 becomes 2 only first. This is the first thing. 4 minus 2 what? 2 bacha 20. And these two in series. So beta, this is the first beta I can say. Click for this question. What's the beta potential difference of battery? Which is 2 volt. Resistance, I can say for this entire wire, that is 4 ohm. This is 2, this is 4. Now, student, you can say this is junction point. Now, literally, beta, it's pretty easy to solve questions. Literally, beta, it's pretty easy to solve question. Yes, beta ji. Now, have a look. So this is remains 2, already mentioned here. This is 10 beta, this is 2. Student, here, this point, I'm considering as a junction point. So this is nothing but it's x. This is what my dear x. So beta, again, you have to apply summation of current is equal to 0 by party. Okay. So let us, student, I'm calling. This is I1, this is I2, this is I3. So entire summation of current like I1 plus I2 plus I3, which is equals to 0. So but what is I1 here? This is a higher potential minus to plus plus. So we can tell which x plus 2 by 4. Beta, this thing already I taught yesterday beta in the classroom, how plus minus minus plus. It's beta, I can sign convention of circuit. So beta, this is x beta minus 2 plus plus by 4 beta. Then x beta, what you can say plus 2 minus minus. So x minus 10 by beta, this is 2 ohm. 2 plus beta party x plus 2 minus minus x minus 2 by 2 is equals to which I can see this is what 0. But I just take care. LCM is what? LCM is beta 4 only. So this is x plus 2. 2 which I multiply. So 2x minus 20. Then beta I can see 2 here. So this is 2x minus 2 to the 4, which is equals to beta 4 beta just to cross multiply. Goes to 0 बच्चा. So x plus 2x, 3x, that is 5x. 5x minus beta, 24. So you can say this is minus 22 is equals to 0. Did I said actually final practical tomorrow. I don't know. I'll see it after coming. Yes. Oh, beta. But, yes, beta. All the best, beta, for tomorrow exam. My dear, all the best, beta, for your tomorrow exam, bacha. God bless you, bacha. Okay, so beta, what you can see? 1x, 2 is 3x plus 5x. 5x, beta, what you can see? 20, 22, bacha. So x, beta, finally you will get. Student, x, you will get finally. X, beta, you can write. This is 22 by 5. Now, beta, further you can solve. This beta, this x point, you can take potential, bacha, 22 by 5. Student, you can take potential bacha 22 by 5. Bacha further solve, you will get current in all circuit. Further solve bacha party, you will get current beta in all the circuit. Okay, fine. Bacha, God bless you for reaction, my dear. Okay, fine. Bacha ji, after this, beta have a look next question. Beta, have a look beta. Next question. Yeah. What's the question? Question remains same. Find flow of current in the circuit. Students, questions remain same, bacha. Find flow of current in each circuit. Okay, fine, bacha. So let us just I want to draw the diagram here. First, I'll draw the diagram. Then I'll take data, right? Yes, beta. So now we can say all resistances in the circuit has a resistance 2 ohm. This is, but I can say 2, 8, and 6. Question remains same. Find flow of current in a circuit. So beta, here student again, I'm considering this is what junction point. So student, if this is junction here, so current will flow. We can say this is I1, I2, I3. So x beta plus to minus minus. So student KCL, according to KCL, summation of current is equals to 0. So this is what my dear x minus 6/2 plus x minus 8/2 plus x plus 2 minus 2 plus plus 2/2 is equals to 0. Now what I can say it is all beta 2 to 0 0. This all beta 2 to you can say what was I party 0 0. Okay, so this is x plus x 2x plus x 3x. This is 3x minus beta g 12 which is equals to 0. So you can say x is equals to 4. You can say what x is equals to 4 volt. Now I can feed here entire value over there x. Then you will get current in our circuit. Then student, you will get current which are in all circuit. Right, my dear? Okay, fine. Further you can solve the chapati. Further you can solve the chapati. Okay, have it with chapati next questions. One more question for this pattern. Then I'll do a few questions based on yesterday class. I didn't question based on like I, J, N, E, A, B, D and all. Questions remain same better. Find flow of current in its circuit. Figure shown. बच्चा जी figure shown. Yes, beta, you can take like that. This is beta जी condition. Yes, beta. Yes. Beta, this is 2, my dear. 2, 2 and 2. You can take 10 volt, 8 volt, 6 volt. So student, according to KCL, what is the first thing which you can keep in your mind? You have to first consider junction point, which is what X, which is what, my dear? X only. So beta J, again, you can say this is I1, I2, I3. So according to KCL, you can write summation of current which is equals to 0. I1 beta G, this is I2, this is I3. I1 plus I2 plus I3, which is equals to 0. So I1 beta, you can say x minus 6 by 2 plus beta G, x minus a plus plus here, x plus 10 by 2 plus beta x minus plus 2 minus minus x minus 8 by 2 to beta entire 0. So x plus x 2x plus x 3x. You can say 3x minus 8 plus 6, 14. 14 minus beta, you can say plus 8 minus 4. Minus 4 is equals to 0. X beta 4 by 3 volt. Now we can fit the value of x. Let us suppose I'm finding an I1 once. I1 beta what you can see this higher potential you are considering now. So you can say 4 by 3 minus 6 upper beta G2. So you can say 6 is the 18 by beta G6 minus you can say what's 14. 14 by 6 minus 7 by 3. Minus what implies here? What is the meaning of beta minus over there? Just directions, what you have taken. This is wrong direction. Direction must should be opposite according to sign convention. So beta I1 here, further you can find which are further also. I2 as well. Beta G, I2 as well. So what is I2, my dear? Yes. I2 beta this circuit. So I2 you can write x plus 10 by 2 beta G. So this is x beta how much? 4 by 3 plus 10 by 2. So 4 plus 30 by 2 bacha. So this is 34 by 2. Got my dear? 34 by 2. So further you can beta also find what you can say I3. You can also find beta G, that is what I3. Now beta have a look next question here. You can have a look next question. So beta find current in each wire. Question remains same bacha. Find student find current in each wire. Beta figure show. My dear, figure show. Right, bacha ji. So bacha ji here you can see this I'm doing beta circuit here randomly anything. First beta I'll do the circuit, then I'll give you the data. Yes. Now beta, all resistances as usual, you can take 2 beta G2, beta G2, right? All beta remains same. Beta you can take, this is 15 volt. You can take beta G, this is 25 volt. This is beta G, 30 volt, right? And there is a potential difference with plus, so you can say this is 100 volt. You can take like that. Beta G, this is 50 volt. You can take. This is you can take 75 volt current flow from this side now. So you can take 0. You can take my dear 0. Okay. So bacha ji, here again here apply same thing. Here bacha again we have to apply with the same thing here. So beta ji, this point you can take with a junction point. Don't be hesitate. It's not a tough question. Yes, sir. Asked. Jay asked beta this question multiple times. Right. So have a look. I can see for solution. Beta, this is your x. You can see beta, this is direction of flow current. You can say I1, I2, I3, I4. So this is beta x minus 2 plus plus. So x plus 15 by 2 plus what about it? X is here and here is 50. So current will move from this side to this side. Plus to minus minus. Beta, this is what you can say beta party minus now. Okay. So beta you can say beta for this condition. And this is beta remains here. Beta we are moving like this side here. So negative only. So minus 30 minus 50 minus 80 beta. You can say x minus 80 upon which this is what 2 x beta. This is what, minus 75 here. This is what beta you can say minus 75 now. So x beta party you can say for this condition. You can say beta party for this condition here. X minus beta plus to minus 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 75, right? So with beta here you can say for this condition, yes, beta remains 2 plus beta x minus 2 plus x minus sorry minus 2 plus 25 upon beta party what you can say. Okay, there is also changes here which you can take in consideration. Correct only no? Correct only no, bacha. Okay. Bacha, this is what? But this is higher potential. So you can say this is again minus. This is what? Again minus here. Upon which you can see this is 2. A is equals to further 0. A is equals to beta what? You can see further 0. Beta again here. I'll just go through once. This is what? Minus minus plus. Correct only. X was a party. Plus 2 minus minus. X minus we can say first. Minus beta and this is minus here. So this is what? Plus 80 here. Keep in your mind. It says this is what? Minus minus plus. Correct. Remain correct with party. No need to worry. 2 beta entire 0. So you can say x plus 15 plus which party? X plus you can say 80 plus which x plus 75 plus beta is x minus 75. 0 beta party. You can see this 75, this 75 cancel. So this is x plus x, 2x, 3x, 4x. 4x is equals to beta minus 95. Sir, for your experience, can you tell me how practice is practical for final vote? Easy beta. Human easy, literally beta, easy. Easy with a human. Easy बच्चा woman. No need to worry. Now बच्चा we get finally beta we got x. Beta put the value. We'll get all the values. So this kind of question beta JEE means already asked beta the multiple times. JEE main बच्चा party already asked not a single time, multiple time, more than one time बच्चा. So this kind of question literally you have to do practice because otherwise if you do the question in paper hall first time, so you will suffer. You will suffer, my dear. So beta have a look next question. Yeah, question remains same, bacha. Questions remain same. Fine. No, but I'm trying to connect here. What is the maximum possibility of numerical easily, so that you can at least each and every candidate can go to average score of physics anywhere. Bacha, find flow of student current in each circuit. Okay. So now student, this is correct one, bacha. Very good, beta. I'm very happy to see, bacha, your confidence, bacha. Literally, in live session, if someone is replying, but I can't imagine, beta, how I'll be happier. Yes, I can say, beta, during 8th class, yeah, in the 7th class, like 8, like say 11th class in the evening session, I was too happy because there are many competitors just there, each and everyone competing each other. Hmm. Yes, beta ji. So this is the diagram for this question. Hmm. Now, beta, I'll just give data here. What's the question, bacha? But the question remains same. Find the flow of current in all circuit. Find the flow of current, bacha, but in all circuit. So this is students. I can say 100 ohm. Uh, take care easy. This is 2, 2, and 2. Okay. Uh, you can take what this is 20 volt. This is what you can see 20 volt. But it's very easy, literally easy, not tough at all. So what I do one thing. Again, you can take what this point as a what junction point. Beta, woman, reply me answer this question. Solve it first. Then I'll be solve. You have to solve first, beta, then I'll be solve. Beta, God bless you for reaction. You solve beta first, woman. Beta, then I'll be solve. Are you solving beta party or I have to solve? Okay. Okay, woman, are you solving or I have to solve? Uh, maybe is that network issue. I don't know. Student, God bless you for your reaction. Now, beta, this is X, beta. This is what you can say 0. Right. So beta this and again you can see 0 here because same connecting wire. So this is beta is 100 volt. So you can see this is 100 volt. Beta have a look at what solution. Beta how much? Junction 1 bacha party. So x minus 100 by 2 plus bacha x minus 0 by 2. You can say bacha x minus 0 by 2 plus bacha party x plus 1 is minus bacha x minus 20 x minus 20 upon beta g 2 is equal to 0 beta. 2 beta to take beta LCM everywhere. So goes to 0. 1x, 2x. This is beta. You can say what? 3x here. So beta 1x, 2x, 3x. This is beta what? You can say 3x. Minus beta is what? You can say 120. X beta is you can say 40 volt. Yeah, I wanted to check with the previous questions here. Yes. Uh, hmm. This is correct only. Oh, this is wrong beta. Woman, it's minus only. X minus only beta, potential difference. x minus only beta. Hmm. Hmm. Plus to minus only. Plus minus to plus. This is not correct only beta. This is wrong. 1x, 2x, 3x, 4x. 4x there. Plus beta is 15 minus 80 minus 75 minus beta is 75. So we can say 4x minus 150 minus 150 beta, and this is 230, 245. 4x beta g, this is, you can say, minus 15 plus beta g 230. 115 beta correct 230. So 4x is equals to, my dear, this is, we can say, 215. So x beta g 215 by 4 volt. Yes, beta. Now, beta, I hope so. Beta, you will get x finally here. Beta, once you will get x, beta, further you can solve with party. You will get all the things. You will get all the things with party. Okay, now beta, KCL finished. I wanted to cover with that is what KVL. That is what, my dear. Next one. This is what KVL. Kirchhoff's voltage law. Bachaji, Kirchhoff's voltage law. Okay, so what's beta KVL? Or beta, you can also say Kirchhoff's second law. Student, KVL based on principle of conservation of energy vector. This is what vector based on conservation of बच्चा energy. Yes, बच्चा. Beta, you know, beta asked by J. J beta asked me this question, but as in multiple time. As a theory questions. As a theory question. Kirchhoff's law based on what? Kirchhoff's first law, Kirchhoff's second law. So first law beta study as idea, conservation of charge. This is about conservation of energy. What is the beta? I can see statement here which you can consider, take in consideration for KVL. According to principle of KVL stated that voltage around loop equals to the sum of every voltage drop in the same loop for any closed, I can say, network is equals to zero. Simple bacha. You can say here mathematically. In KCL, what we are doing, entire summation of current for the circuit is equals to zero. Here what you can say, entire potential you can say, which is what is equals to zero, which is what bacha, you can say is equals to zero. Now, bacha ji, just have a look next year. So this is beta, you can say beta E1 R1 bacha ji. Now, students, you can say this is E2 R2. This is what, my dear, E2, and this is what R2. So this is point A which I can take. Let us suppose I'm considering current moving like this. So this is current I, this is current I, this is current I, this is current I, this is current I. So beta, I said study in the classroom. The student on the battery sign convention according to potential. So this is what I can say what minus. This is what beta lower terminal of battery beta you can say minus, higher students you can say plus. So this is plus, this is minus, right? So let us suppose beta I'll take consideration from here, or I'll take from here bacha. So this is what you can say VA bacha, plus to minus minus. So you can say minus E2 beta on current beta register according to directions of flow current. So you can say this is plus, this is what minus. This is plus, this is what minus beta. This is plus, this is what minus bacha party. So I can say bacha plus to minus minus beta plus to minus minus here. So minus you can say I R2 bacha plus to minus 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 I R1 bacha minus 2 plus 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 E1 is equals to 0. Simply bacha, you can say finally bacha, if you will come again same point. So you can say minus of VA. This VA finished. So finally you can write bacha G E1 minus E2, which is equals to I into R1 plus R2. Simple bacha. Right. So finally you can write current expression over here. E1 minus E2 upon bacha R1 plus R2 upon bacha R1 plus R2. So they can ask bacha anything. Maybe they can ask potential difference on I can say individuals. I can say circuit as well. So this is beta I can say about KVL. Now onwards, bacha, I wanted to discuss next concept, that is combination of resistor. That is what, my dear? Combination of resistor. So student, I can say combination of resistor. What is the point beta which you can take in consideration? Student, there are two kinds of, not two times, there are two types. Student, there are two types of what I can say combination of resistor. Student, there are two types of, you can say, bacha, combination of resistor. Okay. Bacha, you can say this is first one. Student, series combination. Beta, what is markable point which you beta keep in your mind? Beta, I remains same everywhere. I students remains same in the in the beta entire circuit. Yes, beta. I beta what remains same for entire circuit. Right. Uh, let's beta have a look of example here. You can say there is this is R1, this is R2, both student connected through V volt battery. V bacha, this is R1, this is R2. You know what's the things you can say? But these two register definitely can write potential difference, different one. Drop over there. This is V1 and this is drop on. I can say this is R2, which is equals to V2. So you can write my dear. V is equals to V1 plus V2. So what is V bacha? What is this is, you can say, I into R equivalent. I into R1 plus I into R2. I better consider this. So we can write R equivalent, which is equals to R1 plus R2, which is equals to R1 plus R2. Now students, next have a look here. Parallel combination, which is a parallel combination. So we can take for consideration, this is beta R1 and I beta. Entire circuit beta you can take for consideration connected to V volt battery. Beta you can say my dear R1, R2. And this is I beta now. This current divided into part I1 and I2. So here beta, what you can write? This is I is equals to I1 plus I2. But I know what's the things which is remains same for entire circuit. That is what is potential drop, which is equals to, you can see V. V also, because if we have how many things I have taken here two only. If more than two also for all the condition, what you can say potential difference remains same, potential drop remains same for all circuit. So I would say what you can write, V upon R equivalent, V1 upon R1 plus beta G, V2 upon R2. But you know V1 V2 remains same, bacha, which is V only. You can say cancel bacha. So finally beta you can write 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2. So, I'm giving here one points which you can keep in mind for only two resistors. Beta I can write for this condition R equivalent R1 into R2 upon which R1 plus R2 upon which I got what R1 plus R2, right? So this is beta I can say basics combination of beta KCL and KVL, KCL and KVL, right? So just do beta practice of these also beta KCL and KVL. Beta easy question I'll take here so that you can make a grip. Beta you can take this is 3 ohm, this is 6 ohm. The student you can say this is 3 ohm, this is 6 ohm, this is 18 volt. What is the questions? Find following. First, with the current in the circuit. And second, with the drop on both resistor. Drop of potential difference V1 and V2. So let us see, student, I'm considering here for solution. I'll better solve here. That is, I think that like circuit for question diagram. Now, students, you can say this is 3, this is 6, this is, you can say 18. Beta, this is 6, this is 6, this is beta V1. This is what V2. Beta, first we have to find IS. I is what? V upon R equivalent. R equivalent is 6 plus 3 beta is 9. I is equals to 3 ampere. Now it's so V1, you can simply find what's it. I remains same actually. My dear, I remains the same everywhere. As you know in series combination, so I into R1. So it's 3 into 2, which is what you can say beta is 6 volt. V2 which I into R2. I beta remains 2 into beta 6, yes, 6 to the 12 volt. So this is one answer for this question. My dear, this is the answer for these questions. Okay, beta, have a look next. Have a look, my dear, that is what next. Beta, in this question, student, in this question, again, you have to find, find flow of current in all circuit. Or better, just let us discuss here a few different kinds of concept. Now, I'm going to change the questions pattern here. This is, you can take beta 10 ohm. This is 25 ohm. First, I'll make that here. Then I'll take. Take beta 100 ohm. This is 30 volt. What I said here, 100 volt beta, not ohm. This is beta, I can say 6. And this is 8. Now, beta, you have to find following. Beta, current in the circuit. Beta, you have to find current in the circuit beta first. And second beta, the potential drop. Potential drop like V1 and V2. Okay, so student, have a look solution of these questions. First, redraw the circuit here, or I can say rearrange the circuit. Let us suppose you can say, sir, this battery has a tendency to current to flow in the what left direction. So definitely this current, I can say this battery is more stronger. So this is what I can say for entire circuit direction of flow current. Let us, you can understand, let us, you are considering your motion started from here only. So minus to plus plus. So this is what you can say plus, and this is what you can say plus minus minus. So 100 plus and 30 minus 70. So first beta, you have to rearrange the circuit. And 8 plus 6 in 14 beta. 8 plus 6, what you can say 14 in series. So this is first you have to draw circuit, rearrange the circuit first. It's very simple, yeah. You can see this is 70 beta. A and 8 plus is what 14. So I is labeled it V by R, which is 70 by 14 by charge. So I is equals to my dear 5 ampere. In second part beta, we have to find here. You can say V1, we have to find a simple. So entire drop will get on the common resistor only. So what's the drop here? What's the big deal? This is what means 70 volt. This is what remains with the party 70 volt. Okay, have a look with the next question here. Yes, beta. Have a look with the party next questions. I wanted to do this question here only. Hmm. This kind of question is asked in J2026. This pattern of questions, if you are practicing here only, then will get benefit, I can say, examination hall. If you will not make practice over here, means like a normal classroom anywhere, then it's literally very tough. It's literally very tough to just solve this kind of pattern of question in the paper hall. So what's the question here? Have a look once. I can say exactly this. They ask these questions on here. This all are, I can say, with a very very standard question here. And first I'll do the circuit here, then I'll take data. Yes, this is now circuit completed. Now which is circuit completed. This question beta you can do. This circuit treatment you can do by what? I can say beta G KCL KVL, right? But I don't want to do this question. I can say, but the junction law you can apply beta. But my mean to say you can do this question by loop method. Beta, this just writing here. Find value of current in a circuit. Find value of current in its circuit by loop law beta. Okay. So bachcha ji here, be careful here. How can we think? Bachcha, let us suppose data first I have to take now. Take beta ji. This is 50 volt. Hmm. Beta, you can take this is 50 volt, 75 volt. This is 80 volt, bachcha. This is 80 volt, right? Okay. Bachcha body for this condition, you can take a resistor. You can take beta. This is all are 2 here. This is 2, 2, and 2. With this solution, beta, I'm just taking data here. Now, let us suppose beta, I'm considering over here current flowing from here. This is what I. This is what I. Okay. So this is I bachcha body, and this is entire loop beta. I only. This is what entire bachcha. So let us suppose some I value divided in this part. So I'm calling this is what I1. This is what I1. So what is current over here, my dear? You can say I minus I1. Listen carefully here. I'll solve this question slowly. I minus I1. Now, bacha, so here you can write beta g I minus I1. I minus I1. So this is beta current remains same here. This is what I1. Here student again you can say current remains same I1. Okay. So student, there are two methods to solve this question. One time you have to apply loop law here, one time here, or you can do like this: one time apply here and one time for entire loop. Remains same only. Remains same only, bacha. So have a look. What I'll consider. This is I1 bacha party, and this is what current remains I. I hope this is beta which I shown. It's this is beta current distribution. This is what, my dear, current distributions. Very nice. Beta after here, let us suppose I'll take a charge. This is loop number one. This is, my dear, loop number two. So this is beta. I'll take care this type of consideration. Right? Like this here, clockwise, you can say. Okay. So beta, if I'll move from here to here, beta, so what is the minus 2 plus plus? So student, first I'll solve for loop 1, beta. Minus 2 plus plus. Then beta current, as I said, on register direction or you can say sign convention according to direction of flow current plus minus V minus IR. Minus the charge you can say 2I. Okay. Then beta, this you can move beta from in this direction there. So this is what, my dear, you can say beta plus 2 minus minus 75. Minus 75 beta. Again here you can take plus or minus beta. So you can say beta plus 2 minus twice of I minus I1. Then beta party plus here. Beta from this side. This is what, my dear. Beta, God bless you for your reason, student. This is beta party. You can see. Now, this is loop here, complete loop. So again, beta plus 2 minus plus 2 beta, what you can say? Minus plus 2 minus 2I, which is equals to 0. Which is equals to 0. Now, beta, have a look here. So this is what, 50 minus 75 beta. How much? Minus 25. Minus 25 minus 2I minus 2I plus 2I1. Again here minus 2I, which is equal to 0. But I will get your equation over here I and I1. So what you can see, 2I, 2I, 4I, 2I, 6I minus 6I plus 2I1 is equals to 25. Say equation number 1. Say equation number 1. Say बच्चा party what? Equation number 1. Okay. Then बच्चा, I can say for this condition, this is what? For loop 2. What बच्चा party? For loop 2. Okay. So beta for loop 2 here, just apply बच्चा party like this. Again, I'm considering in same location here, in clockwise. So minus 2 plus plus student for loop 2. Beta minus 2 plus plus. So this is what you can take 80 volt. Minus 2 plus beta plus only now. Then बच्चा, this is what? Minus 2 plus. This is plus, this is minus. So minus here. Minus twice of I1. Then बच्चा party here. Yes. Minus a plus plus. This is plus. Twice student you can say I minus I1. What बच्चा party you can see twice I minus I1. Then बच्चा party minus a plus plus 75 beta. this transition here minus 2i1 minus which was the 2i1 which is equals to 0. See carefully which is what is minus a plus, sorry, plus to minus minus, then which is what is minus 2 plus twice if minus i1 minus 2 plus, yes beta, plus to minus, correct, everything is fine. Now it's a what you can say that this is 80 and 5, 75 means 5 only. So this is 5 which is what is minus twice i1 plus 2i minus twice i1 minus twice I1 is equals to 0. So what's here you can see minus 6I1 plus 2I plus 2I which is equals to minus 5. See question number 2 minus, but I'm writing once again here minus 6I plus 6I1 plus 2I which is equals to minus 2. Equation number 2. Now what's just better add these two equations. So here student I'll multiply by 2 and here we can multiply by 6. So what about first equation student? Writing, student, I'm writing here. I can see calculation apart. But this equation multiply by 2 here. So you can say this is what? Minus 12i beta. 2 to the 4. 4 which I see what you can say I1 is equals to which I can say 50. Beta here. 6 is a 36 minus 36 I1. Student, God bless you for direction. 6 to the 12i which is equals to which minus 30. So now student, this is cancel. Now which so what you can say minus which about 36, 32, 32 I1 is equals to which about my plus 20. So I1 you will get here finally. How much better? This is 20 minus 32. So I1 you can write 4, 8, 5 is 20. 5 by 8 ampere. I1 is beta. So I1 now we are getting negative here. So just beta just reverse your direction. Just bachaji what you have to reverse your direction bacha body. Simple. Okay. So this is the kind of question which you can keep in your mind and literally it's highly required, my dear student. This kind of questions are literally very highly required. I can say for the coming examination, either you can take beta mains or CBSE also. This is also beta very favorite for CBSE as well. So student, I can say you have to just practice more. You have to practice more or in the paper hall. Student, you have to more careful. In the paper hall, Betaji, you have to more careful so that you can solve this kind of question without error. Because there is very high probability of, I can say, error in calculation. So students, keep in your mind these all kind of things. Simple error. Just avoid beta, I can say calculation in the paper hall. It's beta highly required. Okay, beta, I'll do one more question here based on this. Yes, I'll take care this time easy data so that I can solve this question completely. Yes, beta Z. Okay, come to the point. Beta Z, this question, have a look. Yes, beta. First, I'll do the circuit. Right now, beta. Then, student, I'll give you data of the questions because I have to frame the data according to questions. So first, I'll make possible. Yes. Now, circuit completed. Hmm. The as usual, I'll take care. All resistances which is available in the circuit, beta resistance to, बच्चा जी resistance to, right ना? Okay. बच्चा, you can take EGR 20 J 5. Beta, we wish to find same thing. We wish to find same thing, not from junction law, loop law beta. Student, we have to find same thing, find flow of current. Student, find flow of current in a circuit. So it's a tough here, but listen carefully, beta. You can do this question here. It's not tough at all. Okay. So beta, first I'll take consideration here. First, student, I'll take consideration. How? Hmm. Let us suppose, beta, this is the directions of flow of current in the circuit. So I'm considering this is what I, or you can take here I1, I2. Let us suppose this is what I1. So you can take beta, this is what remains I1. Beta for circuit in series beta, you can say this is also I1. This is also I1. Right. Bacha ji, for 5 volt here, I can say for this condition, something you can take it a different. Let us suppose this is what I1 beta. So minus a plus, current will flow like this, no? Current beta will flow like this. Okay. So minus to plus bacha party. Okay. We can take do one thing, a little change. I'll do little changes in these questions. You can take 100 volt. This is beta also you can take 100 volt. This is 200 volt. Yes, sir. I wanted to just solve it as some different method or some different kinds of category. But again, I'm repeating. But this is 100 volt. This is also 100 volt. Now, this is very fine. So now, which I can say current, yeah, maximum will go from here. So, better this condition. You can write this is what I2 current. It's fine. So, this is student I2 current. What is current over here? I1 plus I2. This is now satisfying with everybody. Satisfying here. So here also current you can say I1 plus I2. Yes, with everybody. This is the point at which you can keep in mind. Just I wanted to highlight with everybody everything here so that you can feel comfortable at physics point. Because this is I1, my dear. Because this is I1. Because this is I1. No, because this is 200 volt here. So maximum current will pass from here only. And this current divided into part. Yes, beta G. Everywhere you can say this is what I do. Okay. So now wait, I'm considering you can take this is loop number 1. This is what my dear loop number 2. So beta this condition, current move like this. And beta this one, current move like this. Both are opposite with party. Because current beta now dividing. Current beta what now? Dividing my dear. Okay. So which will be for this condition. First beta I'll take for consideration for loop number 1. Student for loop 1. Okay. So this is loop 1 beta buddy. If this is loop 1 beta, then what I can say? Beta minus to plus 100 volt. 100 volt beta buddy. Then beta here plus to minus. Already I said multiple times. On resistor sign convention according to directions of flow of current. So this is beta party you can say minus this is what 2 I1 beta this side here. So this is you can say again here minus twice of I1 plus I2. Same beta you can apply beta sign convention plus to minus on resistor sign convention according to on resistor sign convention according to direction of flow of current. Beta minus 2 I1 plus I2. Beta again minus 2 plus plus. So this is what, my dear? 200 volt. Then with minus 2 plus to minus. Keep in mind, it's literally toughest thing. Be careful in the paper hall. Beta is this one. Plus to beta minus minus here. So you can see minus twice of what's party? I1 plus I2. Again what's party? 2 to 4 you can write directly with party. This is beta 2 to the 4 beta. 2 to the 2 plus 2 4 minus 4 into I1, which is equal to 0. Which is equal to which party? What can you say? 0. Now beta, just be careful here. What you can say? 200 plus 100 here. This is what you can write 300. Beta 300 here. Minus student 2 of I1 minus 2 I1 minus 2 I2 minus 2 I1 minus 2 I2 I2 minus 4 I1 is equal to 0. Now what's that? You can see here. This is 2 I1 with that 2 I1, 4 I1 plus 2 I1, 6 I1 plus 4 with that 10 I1. So this is 300 minus 10 I1, right? Minus 4 I2, which is equal to 0. Which is equals to 0. Okay. So students, you can write like this. This is minus, which I can take common. 10 I1 plus 4 I2 is equals to minus 10. Cancel here. So 10 I1 plus 4 I2, which is equals to 300, equation number 1. This is what, my dear, equation number 1. Okay, now I'll apply here. I can say for this is KVL, na bacha? KVL we are doing now. Yes, KVL bacha. V is equals to IR. So beta, you can see this is next one for loop 2. This is what, my dear, for loop 2. Okay, for loop 2 bacha. So what we can say, plus 2 minus minus 100. Beta plus 2 minus minus here. And this is again plus 2 minus 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 2I2. Beta is again here plus 2 minus minus 2I2. Here bacha party minus twice of I1 plus I2. Minus 2 plus plus which I think 200 beta minus twice of I1 plus I2. And here what's about again here minus twice I2 is equals to 0. Minus what's party twice I2 is equals to 0. Okay. Bacha ji, just be careful here during calculation. 100 bacha plus 200 minus 100 plus 200 becomes 100 only, my dear. This is 100 bacha minus 2 I2. I'll use here next pen, little dark. Minus 2 I2 minus 2 I1 minus 2 I1 minus 2 I2 which is minus 2 I1 minus 2 I2 minus 2 I2 is equals to 0. It's 2 only. Okay, be careful here. I can say this is minus 2 I2 minus 2 I2, 4 I2. This is 6 I2, 8 beta. So you can say 100 minus 6 I1 minus 8 times of I2, which is equal to 0. So here, bacha, I can say can write, my dear, as usual, same here. This is 6 times of what, my dear? 6 times of I1 minus beta is plus 8 times of I2 is equals to 100. Equation number 2. Now, beta ji, you have two equations here. I can say two unknown, solve with Sabati further, right? So definitely it's a strong recommendation for each and every candidate. It's a strong recommendation for each and every candidate before be a part of CBSC, before be a part of second attempt of, I can say, J main session 2. Please do this question practice a lot, because I1, I2 in the paper hall, how you have a time important. So do these questions here literally highly required, and do hard work at home to remember this pattern of questions. This pattern of question. Oh, okay, bacha. This is all about today class here. Student, I'll see you tomorrow. How I'm going to stop live session.